1. Sequences and series. Who's not? It's time to Mr. Klein. He knows what to do. Alright, so let's look at our 8-1 here. What we're going to be doing with this lovely section here is we're going to use sequence notation to write the term of sequences. We're going to use factorial notation. Whoop, something new. We're going to use some summation notation to write sums, find sums in infinite series, and use sequences as a series to model and solve real-life problems. So, sequences. In math, the word sequence used just like you would say it in ordinary English. Collection is listed in a sequence means it's ordered, so it has a first member, second member, so on. So it's in an order. There are certain numbers that are in a specific order. So mathematically, you can think of a sequence as a function whose domain is a set of positive integers. And keep that in mind, your domain is always a set of positive integers. It does not include negative integers like -1, -2, or 0. So instead of using function notation, though, sequences are written as subscript notation. This is going to be shown in your following definition. So if we look at our following definition, an infinite sequence is a function whose domain is a set of positive integers and it never stops. Infinite means your sequence goes on forever. So that'd be denoted by a sub 1, a sub 2, a sub 3. So notice your a sub 1, that is your first, that's your first term, your a sub 2 is your second term, and so on. A sub n is your nth term. That's what we call these, is a term for your sequence. Now remember, once again, your domain is your function of numbers that are your first positive integers only. Then that has a sequence is called a finite sequence. Okay? So that's the difference between infinite and finite. Even pronounced differently. That is cray-cray. So sometimes we might start a sequence with a 0 instead of 1. No biggie here. Let's move to example 1. So what we're going to do is we're going to write the first 5 terms of each sequence. So when we write out each term, we would say it's an a sub 1, an a sub 2, an a sub 3. There's the first 3 terms. So we're going to need an a sub 4, and we're also going to need an a sub 5. Notice your n is your number of terms. So since your n is the same as your number of terms and then your expression, whatever number you have, whatever term is, that's what you plug into your expression. So I'm going to say 2 times a 1 plus a 1. I plug in a 1 because that's my first term. So I say 2 times 1 is 2, 2 plus 1 is 3. Now I'm going to do the same thing with the 2. So I'm going to say 2 times 2, because I'm going to plug that 2 in for the n, plus a 1. So you have 4 plus 1 is a 5. So I see a little pattern here. Now I'm going to say 2 times a 3 plus a 1 is going to give us 6 plus 1 is a 7. I see a pattern big time now. 3, 5, maybe a 9, maybe 11 is going to be next. Let's find out. 2 times 4 plus 1 is a 9. God, I'm so smart. Don't tell anybody. Then they'll want to start knowing more answers to the meaning of life, probably. And then you get an 11. So altogether, your first 5 terms, if you want to rewrite these, we'd say 3, 5, 7, 9, 11. These would be your first 5 terms of this specific sequence. Beautiful. Now for B, this is not as pretty because you have a -1 to the n, so you have an exponent, which is not as nice, but can still be done. So we're going to list out our a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So we're going to plug in 1, 2, 3, 4, 5, n to this expression for our n. So 2 minus -1 to the first. A -1 to the first is a -1, so 2 minus a -1 is a 3. Here's our first term. 2 minus -1 to the second is, let's see, what's that? 2 minus a 1, which is a 1. Lovely. A sub 3, we're going to plug in a 3 here, so -1 to the third power. Well, anytime you take a -1 to an odd power, it's just going to be negative. So you have 2 minus a -1 is a 3 again. Whoa, weird. I came back to the same number I had before. 3, 1, 3. I'm going to guess I'm going to get a 1 here next. -1 to the fourth is a 1. 2 minus a 1 is, I would say that'd be a 1. Yes. 3, 1, and then a 3. So if you notice your pattern, you can almost kind of, I hate to say this, but skip some of your work as you're going through here. So your pattern, your sequence is a 3, 1, 3, 1, 3. That is your sequence, or your 5 terms of your second sequence. Booyah!